For my final project, I chose to research the economic and environmental impacts of tide turbines. In this presentation, I plan to show that tide turbines can have a beneficial economic and environmental impact on local communities and environments if paired with proper planning and economic policy with support from local governments. So first off, what are tide turbines? They are a form of renewable energy that uses kinetic and potential energy from tides and tidal waves to generate electricity. Many types of tide turbines function like wind turbines. However, due to the high density of water, more electricity can be generated at slower speeds. Some common types of tide turbines are barrage turbines, horizontal axis turbines, vertical axis turbines, bidirectional turbines, which are a type of horizontal axis turbine, free flow turbines, which is another type of horizontal axis turbine, oscillating water column turbines, enclosed, ducted, and shrouded turbines. Some real-world examples of tide turbines are the Lorentz, which is a barrage technology. This is the oldest form of tidal energy, but it is the most damaging to the environment, so most tide turbines moving forward do not use barrage turbines. Next up, we have the C-gen turbine. This utilized twin turbine horizontal axis rotors with blade pitching systems, which is a type of, again, horizontal axis turbine, and the blade pitching helps reduce things like cavitation and noise pollution. It is currently decommissioned, but in its lifetime there were no significant changes to marine life, and there were minor alterations to seal and bird migration patterns. So this is a good example of how these turbines can have a low impact on marine life. Next up, we have open hydro turbines. This turbine was able to generate electricity during the inflow and outflow of tides, but the project was shut down before any real implementation and connection to the grid. And this turbine is a good example of how economic impacts can make it difficult to actually implement tide turbines into the electrical grid because there are a lot of high startup costs. Next up, we have the Verdant Power, which is a free flow turbine. This is a 3-turbine tri-frame system. It's pretty similar to a wind turbine construction. It improves the performance while reducing costs, and it is still active today. This example shows minimal impact on marine life thanks to the slow-moving blades, which a lot of tide turbines nowadays use. We also have the WaveGen, which is an oscillating water column technology. It is a Wells turbine that generates electricity using changes in air pressure created by tidal waves. The WaveGen Limpet itself is currently shut down. However, the Mitriku breakwater plant, which operates on the same principle of the Wells turbine, is in operation today. We also have the HydroQuest Ocean Quest. This is currently in its research and prototyping phase, but it so far has shown limited impact on marine life due to its unobstructed flow and low sediment displacement. There have been some noise disruptions reported. However, they are still working on collecting more data to further analyze the impact that this has on the environment. Research is still going on, so we will see how that goes. So what are the general environmental impacts that tide turbines have? Starting off with some of the environmental stressors, they can cause changes in the wake, changes in patterns of marine life, such as migration changes, behavior modification, habitat changes. They can have acoustic effects, such as noise pollution and cavitation, which is when high velocities create vapor bubbles, which can trigger shock waves in the water. Tide turbines can also create changes in the sediment deposition. All of these effects can be lessened or aggravated depending on the type of turbine used in the environment. So The technology is also fairly new, and with further research and development, these stressors can be mitigated. On the flip side, some benefits of tide turbines is they eliminate harmful emissions from fossil fuels. They have a high efficiency compared to other renewable energy resources, high energy payback when compared to the installation, operation, and maintenance of these turbines, and they use less land area per kilowatt hour versus other renewable energy resources. Their operation life can be from 20 to 30 years, comparatively longer than some other renewable sources, and they produce relatively less harmful emissions during their construction. Now, looking at some of the economic impacts of tide turbines, it is estimated that they could create up to 1 million jobs by 2030. They also have a high energy payback. It's about 40 times greater than the installation compared to wind energy. Um, it has the potential of having higher or lower energy costs. This is going to depend on the region, and the energy cost for the consumer will continue to decrease as the technology develops. We're looking at about 15 years behind the production of development compared to wind development, so it has a little bit of a lag when compared to the prices of wind energy. Um, the biggest economic impact is going to be the high initial startup cost. However, government subsidies can help reduce this cost. When comparing tidal energy to some other renewable sources, uh, we can look at solar power, which is generally seen as a very good renewable energy resource. However, it does take up a lot of space, which tidal energy uh, takes up relatively a lot less space per kilowatt hour, as mentioned before. Um, and geothermal energy, while it does tend to have an overall positive impact, it does have more of a visual impact. The noise pollution tends to be a little bit higher than tide turbines, and geothermal energy has more of an impact on the actual water quality. When we look at biomass fuels, it really depends on the type of feedstock. Some feedstock fuels can have a net zero impact, but not all fuel sources can absorb as much impact, as much emissions as they give off. So, biomass is kind of a tricky situation on which feedstock you're using, on whether it actually helps or harms the environment. Um, and when you compare it to the other form of water-based renewable energy, the hydroelectric dams, tide turbines tend to have a less of effect on the environment than dams, with the exception of barrage tidal turbines, as they function very similar to hydroelectric dams. But some of the other turbines that are more designed based off of wind power, can have less of an influence on the environment surrounding the actual turbines themselves. So, what's next for tide turbines? Again, there are some disadvantages to tide turbines, the biggest one being the high cost of the initial startup, and it being a relatively new field of study. Um, there just needs to be a lot more research and development before we can really implement tide turbines on a broader scale. But on the flip side, there are a lot of advantages to tide turbines. As we continue to develop this technology, we can make it more dependable. We can make sure that they are not visually intrusive, that they are not affecting the marine life in a negative way. Um, And so some of the best ways that we can implement these turbines, if we combine them with offshore wind turbines, they can have a even higher efficiency, up to 40% higher. Um, and if we use better storage technology to make the most use of the energy developed. We can start to um, manage more grid systems that are net zero or uh, at least more environmentally friendly grid options. In conclusion, tide turbines offer a great alternative to fossil fuels, and due to its relative newness to the field of renewable energy, there is a lot to look forward to in its research and development. While getting over the challenges of high costs and relative uncertainty is going to be a significant hurdle, if companies and governments can work together, we will see huge advancements and benefits in the implementation of tidal energy to the electrical grid. All human activity comes at a cost, and when comparing the economic and environmental cost of tidal energy, the long-term benefits make this renewable resource a great alternative to fossil fuels.